Hey there guys, Mr. Trutna here. Here's what we're going to do today. So we're going to go over the zero product property, excuse me, and how it relates to the x-intercepts. You're going to be on page 8 and 9 in your notes packet. So if you have room in page 8, start there, and then you might have to move on to page 9. Okay, so I'm going to say goodbye to you guys. You'll still be able to hear me. Hopefully I'll be able to see you guys soon. Okay, so here we go. So let's go over how to use the zero product property, which we used the other day. And what we're going to do is we are going to go over 4 examples here where we're going to be using the zero product property. And then what we're going to do is we're going to sketch a graph of the of the equation that we have. And then we're going to look at the x-intercepts and how they relate to the zero product property. So as we're doing this, as you're taking notes and we're going over this assignment, always be keeping in mind, how does the zero product property and the answers that you get for the zero product property, how do they relate to the x-intercepts? Okay, all right, so the first example that we're going to go over is x minus 2 multiplied, so the factor x minus 2 multiplied with the factor x minus 4 is equal to 0. So notice in this problem we have 2 factors, x minus 2 being one of them, another factor x minus 4, and those 2 factors are being multiplied together to be equal to 0. So remember, using the zero product property says that in order to get the solutions for x in this problem, what we're going to do is we are going to split this problem into 2 separate problems, one of them being x minus 2 is equal to 0, and the other one being x minus 4 is equal to 0. And then what we're going to do is we're going to solve both of these equations to see what my solutions are for x. So you can see in the first equation that when I solve for it by adding 2 to both sides of the equation, I get my solution of x is equal to positive 2. Solving the other equation by adding 4, excuse me, to both sides of the equation, I get my solution of x is equal to positive 4. So this tells me that my 2 solutions to this equation are x is equal to 2 and x is equal to 4. Okay, now what we're going to do now is I'm going to take this equation, factor quantity x minus 2, multiplied with quantity x minus 4, and I'm going to go to desmos.com, and this desmos.com website, or you can download it on your phone as a free app. It's going to be very helpful for you. One of the reasons is because it has a graphing calculator, and what I'm going to do is I am going to graph the equation x minus 2 times x minus 4, and watch what happens when I do that. So I have the quantity x minus 2 multiplied with the quantity x minus 4. Now when we graph it, we don't have to say it's equal to 0, and you can see over here that we get a parabola when I graph it. Okay, now there's a couple things that I want to point out about the parabola. Please notice that this parabola has 2 x-intercepts. One of them is at the coordinates 2, 0 and 4, 0, and then the y-intercept has a coordinates of 0, 8. So I just want to go back to the notes here, and all I'm going to do is I'm going to make a sketch of this graph that I just made. Okay, and I'm just going to denote where the y-intercept was, which was right up here at 0, 8. And then I'm going to denote where the 2 x-intercepts were, and I'm going back to my graph so you can see it, which was the coordinates 2, 0, 4, 0. And then I'm going to denote that my vertex has the coordinates of 3, negative 1. Okay, so I have an x-intercept at 2, 0. I have another x-intercept, if you recall, which was at 4, 0. And then I had a vertex which was down here, which had the coordinates of 3, negative 1. Okay, so now I'm just going to sketch out this parabola so we can show what it looks like here. And then what we want to do is we want to see, and I really want you guys to focus on what do you notice about the solutions when I used the zero product property, which was x equals 2 and x equals 4? And then what do you notice about the x-intercepts coordinates, which were the coordinates 2, 0, and 4, 0. So notice this right here, x equals 2 and x equals 4, those were my solutions to my equation, which was quantity x minus 2 multiplied with quantity x minus 4. And then my x-intercepts of my graph were the coordinates. I had two x-intercepts. Then they were the coordinates 2, 0, and 4, 0. Okay, so what hopefully you're noticing right here is, and this is only one example, is that the x-intercepts, when we look at what the x-intercepts are of my parabola, those values were exactly what my solutions were. Okay, so my x-intercepts had coordinates of positive 2, 0. One of my solutions was x equals positive 2. My other x-intercept was positive 4, 0. And my solution, another one of my solutions was x equals 4. And then notice when I looked at my equation that I started with, I had one of my factors was x minus 2, and one of my solutions was x equals positive 2. One of my other factors in my equation was x minus 4. One of my solutions was x equals 4. So notice that the solutions are the same as the x-intercepts, and the solutions were the opposite of what you saw in the parentheses in your factors when you started the equation. Okay, and then the last thing that I want you to notice is that we look at the y-intercept right here, which was 0, 8. Notice that for the y-intercept, the x value of the coordinates of the y-intercept was 0. So my x value turned out to be 0 for my y-intercept there. Okay, and then we had the vertex, which was 3, negative 1, and the vertex is halfway in between my two x-intercepts. Okay, so let's take a look at another example of this, and let's verify to see if number 1 wasn't just a coincidence that everything that happened right there. Let's do a couple more so we can see how it looks. So here's number 2. We have quantity x minus 3, so one of my factors is x minus 3, multiplied with another factor, quantity x plus 1, and that is going to be equal to 0. So let's go ahead and let's use the zero product property, and let's see what my solutions are to this equation here. So remember, what we do is we create two equations, one of them being x minus 3 is equal to 0, the other equation being x plus 1 is equal to 0. And you can see, and what I do is you can see that when I solve both of these equations, I get x is equal to positive 3. And when I solve the other equation by subtracting 1 from both sides, I get x is equal to negative 1. So that tells me that for the equation x minus 3 in parentheses multiplied with x plus 1 in parentheses, my solutions are x is equal to 3 and x is equal to negative 1. So either one of these x values would give me a value of 0 if I plug them back in. I don't have to plug them both back in. Okay, so now let's go to Desmos and let's graph quantity x minus 3 multiplied with quantity x plus 1, and let's see what happens when I graph the two equations. Okay, so we have quantity x minus 3 multiplied with quantity x plus 1, and you can see that we get a parabola, and let's go ahead and let's denote the 4 major points of the parabola. So you can see that we have an x-intercept right there at which coordinates of negative 1, 0. We have another x-intercept with coordinates of 3, 0. We have a y-intercept with coordinates of 0 and negative 3. And then we have the vertex, which is coordinates of 1 and 4. So notice that the vertex, the x value is 1, which is halfway in between my two x-intercepts. And notice once again my y-intercept, the x value of my y-intercept is 0. So let's go ahead and let's go back to our notes and let's make a quick sketch of what this graph is going to look like right here. Okay, so once again, going back to my graph, I have a y-intercept of 0, -3. I have a vertex of 1, -4, and then I have my two x-intercepts. So my y-intercept is going to be right here, which was the coordinates 0, -3. I had a vertex down here, which was the coordinates 1 and -4. And then I had two x-intercepts. One of the x-intercepts was at, my vertex was +1, -4. Sorry, I wrote that backwards right there. And then I have two x-intercepts, -1, 0, and 3, 0. So I have an x-intercept right here at -1, 0. I have another x-intercept right here, which had the coordinates of 3, 0. So just making a quick sketch of what my parabola looks like right here, I had this parabola right here. Not the best drawing, but we'll go with it, okay? So notice in my graph, my x-intercepts for this particular equation were the coordinates -1, 0, and the other x-intercept was the coordinates 3, 0. Okay, and once again, hopefully you're seeing a relationship here. So if you notice, my solutions were x equals +3. One of my x-intercepts was the coordinates 3, 0. My other solution was x equals -1. My other x-intercept was the coordinates -1, 0. So once again, the solutions that we got by using the zero product property were the exact same values as the x-intercepts. Also, I want you to notice that when we look at the equation that I started with, I had one factor was x -3. One of my solutions was x equals +3. So once again, and my other solution was x equals -1, and one of my factors was x + 1. So once again, my solutions are the opposite of my factors that I started with. Okay, and then once again, when we look at the y-intercept right here, notice that for the y-intercept, the x value for the y-intercept once again was 0, and then the y value had some value right there. Okay, all right, let's take a look at another one right here, another one that maybe be a little bit more in detail, but it's the same idea. So here's my third equation. It is x squared plus 4x minus 5. So x squared plus 4x minus 5 equals 0. So what we're going to do is we're going to use the zero product property because this equation is equal to 0. But before I can use the zero product property, I have to put this trinomial, this x squared plus 4x minus 5, into factored form. So I'm going to put to use my area model and my diamond problem. And I'm going to factor out the x squared plus 4x minus 5 to see what it factors into, which will help me use the zero product property. So I'm going to put the x squared in the top left portion of my area model. I'm going to put the positive 4x in the bottom of my diamond problem. I'm going to put the minus 5 in the bottom right portion of my area model. And then multiplying x squared with -5, I get -5x squared, and I put that in the top of my diamond problem. Solving my diamond problem, my left and my right side have to be positive 5x and -1x. And the reason for that is because 5x plus -1x gives me a result of 4x, which that's a 4 right there. And then when I take 5x and I multiply it with -1x, that multiplies together to make -5x squared. So I'm going to fill in the two remaining pieces of the inside of my area model with 5x and -1x, and now I'm going to fill out the outside dimensions. So here I have x and x, because x times x is x squared. Up here, I have to have a positive 5, because positive 5 multiplied with x gives me positive 5x. Down at the bottom left dimension, I have a -1 here. Come on. Let's just write it in there. -1, because -1 multiplied with x is -1x. And then notice -1 multiplied with positive 5 gives me -5x. So what this tells me is that my factors are quantity x plus 5 multiplied with quantity x minus 1 That's equal to 0. So now I just factored x squared plus 4x minus 5 equals 0, and now I'm going to use the zero product property, and I'm going to create two equations, and I'm going to solve both of those equations. They're both equal to 0, and I'm going to solve both of them to find my solutions to this equation. So you can see solving the equation on the left by subtracting 5, I get x is equal to -5 for one of my solutions. Solving the equation on the right by adding 1, I get x is equal to +1 for my other solution. So this tells me that for the equation x squared plus 4x minus 5 equals 0, my solutions are x is equal to -5 and x is equal to +1. Okay, now remember what we're trying to do is we are trying to see what is the relationship between the solutions of the equation and the coordinates of the x-intercepts. And if you've been paying attention, you're going to be able to figure it out right away. But let's go ahead and let's go to Desmos.com and let's type in the equation x squared plus 4x minus 5. You don't have to put in the equals 0 in Desmos, and then we'll see what the equation turns out to be. So we have, let's go here, we have x squared plus 4x minus 5. And you can see that we get a parabola. Okay, so there's my parabola. So let's denote the major points of the parabola. You can see we have an x-intercept of coordinates of -5, 0, and the other x-intercept has coordinates of 1 and 0. So going back to my table, my x-intercepts are coordinates -5, 0, and the other x-intercept is 1, 0. And once again, hopefully you see that the x-intercept coordinates are the exact same as your solutions. And then once again, when I look at my two solutions and then I look at my factored form of my equation, notice the solutions were the opposite of what my factors were. Solution of -5, my factors was x plus 5. Another solution of x equals +1, my factor was x minus 1. Okay, so what we're finding out is this is not a coincidence that these x-intercepts are always matching up with the solutions. The solutions are always the opposite of your factored form. So this means I have an if I were to sketch my parabola, I have an x-intercept at -5, 0. I have another x-intercept at 1, 0. Now remember, my vertex is going to be exactly halfway between -5 and +1. And you can see from the graph, my vertex is -2, -9. So my vertex, -2, is exactly between +1 and -5. So my vertex, excuse me, is down here at -2. -9, and then my other major point of my parabola is I have a y-intercept right here, which is at 0 and -5. So let's go ahead and mark that right there. So here is my sketch of my parabola. I have denoted the major points of my parabola, the x-intercepts, the vertex, the y-intercept. Okay, and then notice here that couple things that we've been pointing out. When I look at my y-intercept, notice the x value of my y-intercept is 0. And then the y value varies the number. And then notice also when we look at my vertex, the x value of my vertex, which is -2, is exactly halfway between -5 and +1. Okay, one more example, example number 4. Let's do the same idea here, where we're going, in this problem, it's going to be like number 3, where we have a parabola, and I'm sorry, we have a trinomial, and we're going, but it's not in factored form. So my trinomial is x squared plus 8x plus 16 is equal to 0. Okay, so I'm going to use the zero product property to find my solutions. Okay, so in order to do that, I have to factor this trinomial. So once again, I'm going to incorporate the idea of the area model, and I'm going to incorporate the idea of the diamond problem. Okay, take the x squared, put it in the top left portion of your area model, The positive 8x goes in the bottom of your diamond. The positive 16 goes in the bottom right of your area model. 16 multiplied with x squared is 16x squared. So I'm going to put that at the top of my diamond problem. And then solving my diamond problem out, my left and right side both have to be 4x. Why does it have to be 4x? Because 4x plus 4x gives me 8x. And 4x multiplied with 4x gives me 16x squared. So I'm going to fill in the right and the left portions of my diamond problem with 4x and 4x, and I'm going to fill out the outside perimeter to dimensions to figure out what my factors are. I have an x and I have an x. Up here, I'm going to multiply positive 4 with x to get 4x. Down at the left side, I'm going to multiply positive 4 with that x up there to get 4x. Notice it works because positive 4 multiplied with positive 4 gives me positive 16. So this means my factors are quantity x plus 4 multiplied with quantity x plus 4 is equal to 0. And now I'm going to use the zero product property, and I am going to create two equations to see what my solutions are. And my two equations in this case are exactly the same, so I really only have to solve one of them because they're going to have the same answer. I don't have to solve the same equation twice. And you can see by subtracting 4 from either equation, I am going to get x is equal to negative 4. So in number 4, in this case, there is only one solution to the problem, and it is x is equal to negative 4. Okay, and you don't have to write negative 4 twice. So my only solution to this equation is x is equal to negative 4. Okay, so now we're going to go to Desmos, and we're going to take a look at what the graph of this equation, x squared plus 8x plus 16, makes. Okay, so here we go. Let's go ahead and let's graph it. We have x squared, and then it's plus 8x plus 16, and when I'm done typing in the equation, you can see that I get a parabola. All right, and I'm going to zoom it out just a little bit so I can see the key features. So you can see on this parabola there is only one x-intercept, and it is right there. The only x-intercept is negative 4, 0. It also turns out to be the vertex, and you can see that the y-intercept is 0 and 16. Okay, and then on the other side of the equation, because parabola is a mirror of each other, you can see there's another point right there, which would be the point, and there it is, it's negative 8, 16, that mirrors the point 0, 16, my y-intercept. That'll help me sketch a graph of it. So sketching out the graph of this equation here, there we go, that's what I was looking for. I have an x-intercept, and I only had one x-intercept, and once again, the coordinates of the x-intercept completely matched up with the solution. It was negative 4, 0, which is about right there. There's my x-intercept. And then I had a y-intercept, which had coordinates of 0, 16. And then remember, because I know my x value of my vertex is, and this point was not only the x-intercept, it was the vertex, it's halfway in between, so that means I had another point over here which had to have coordinates of negative 8 and positive 16, and I knew that because negative 4 is halfway in between 0 and negative 8. Sketching out just a graph of what my parabola looks like, it's going to kind of look like that, just a sketch. My sketches are really, really bad today. And there's my equation. So once again, please notice that the x-intercept coordinates were the exact as the solution. The solution was the opposite of what we got for my factors right here. And notice when you just have one solution, that still means you're going to have two factors. They're just going to be both the same thing, x plus 4 and x plus 4. And the last thing that I want you to notice is that when we look at the x value of your y-intercept, the x value of your y-intercept is always 0 right there. Okay, all right, so you guys, there's a lot of information that we have going on. So now what we're going to do is we're going to kind of switch gears a little bit, and what I'm going to do now is I am going to give you a picture of an equation, and from that picture of the equation, what you're going to do is I'm going to give you a picture of a graph, excuse me, and from that picture of the graph, I want you to tell me what the equation is going to be for the graph. So here we have a graph right here, and let's say that the graph has one x-intercept at -6, 0, and then the other x-intercept is going to be at +8, 0. Okay, and I want to know what is and then the parabola for this graph looks something like this right here. Okay, not a very good sketch of it, but there's my arrows, and I want to know what's the equation going to be for this graph. Okay, all right, so here's how you do this. So to write the equation, the x-intercepts actually tell you everything you need to know about the equation, and the reason is because remember, the coordinates of the x-intercept are always the opposite of what the factors were. Like if we went back up here to the number 3, notice the x-intercepts were -5, 0, and 1, 0, and those were the opposite of my factors, x plus 5 and x minus 1. Okay, so using that concept right there, that means that if one of my x-intercepts has coordinates of -6, 0, that tells me that one of my factors is going to be quantity x plus 6. It's the opposite of what your x-intercept is. And then your other factor is going to be opposite of your other x-intercept. And since my x-intercept here is +8, 0, it means my other factor is going to be x minus 8. Okay, so my equation will be y equals, we don't make it equal to 0, we're not using the zero product property, we're writing the equation. And then also remember that instead of writing y, I could write that f with parentheses x, which means the same thing as y. So the equation for this graph would be quantity x plus 6 multiplied with quantity x minus 8. And then if I wanted to multiply this out to write my equation in written out form, in what we call standard form, I would use the area model and I would put an x and a +6 along the top. I would put an x and a -8 along the side. I would fill in the insides with x squared, with +6x, with -8x, and with -48. And then I would combine this and I would get y is equal to x squared. There's my x squared. Then I would combine the -6 or the -8x with the +6. I'd add those together. So that would give me -2x or -2x. And then I would have the -48 right there. So, and there's where I got the -48 from. So this is my graph that I gave you, and either one of these equations would be the equation that would correspond with the graph right there of that parabola. All right, let's do one more here, just so we get the idea here. So here's my next graph. So I'm going to give you a graph, and then I want you guys to tell me what the equation is going to be of the graph. So for this particular parabola, I have an x-intercept at +1, 0, and then my other x-intercept is at +7, 0. All right, which means that my vertex is going to be down here, and we know that the x value of the vertex is going to have to be at 4, because 4 is halfway between 1 and 7 right there. And so this is what my parabola looks like. I'm just putting a sketch of my parabola here. Okay, so then once again, I want to take this graph and I want to figure out what the equation is for the graph. So remember, the factors for your equation, and you're always going to have two factors, are always the opposite of your x-intercept. So if one of your x-intercepts is +1, 0, that means one of your factors is quantity x minus 1. If your other x-intercept is positive 7, 0, it means your other factor is quantity x minus 7, and you're going to make the equation y equals. Or once again, you could say f with the parentheses x, f of x, which means the same thing as y. So that would be your equation in factored form. Okay, if I wanted to multiply this out, x minus 1 multiplied with x minus 7, all I would do is I would set up my area model. I would fill in the outside dimensions with x minus 1 and x minus 7, and then I would multiply to fill out the 4 inside parts. X squared minus 1x minus 7x and positive 7. So that means this would multiply out to be x squared. There's my x squared. And then I can combine the minus 7x with the minus 1x by adding them. That would give me minus 8x and then plus 7 from this positive 7 right there. So my equations that would match up with the graph would be either y equals quantity x minus 1 multiplied with quantity x minus 7, or y equals x squared minus 8x plus 7. Okay? All right, last thing that we're going to do is, so the last thing that you're responsible for knowing how to do is going from, so what I'm going to do in this problem is, I'm going to give you a table of values. So going all the way back to the beginning, notice we said we're going to use a table. Number 2 is we're going to use a table of values to identify the x-intercepts and the y-intercept, and we're going to write an equation. Okay, we already did number 3 where we used a graph to write the corresponding equation. Okay, so here is my table of values. I'm going to give you some values here. I'll give you 6 or 7 values right here. So when x is negative 7, y is positive 5. When x is negative 6, its corresponding y value is 0. Negative 5 of x corresponds with negative 3 of y. Negative 4 of x corresponds with negative 4 of y. Negative 3 of x corresponds with negative 3 of y. Negative 2 of x corresponds with 0 for y. Negative 1 of x corresponds with positive 5, and 0 of x corresponds with 12. Okay, so what I want to do is, in this problem, I want to identify the x-intercepts, and then I want to identify the y-intercept, and then I'm going to then write an equation that matches up. I'm going to write the equations that match up with this table right here. Okay, all right, so I'm going to do it without graphing. So just remember that anytime you have to identify the y-intercept, like we've said numerous times in our notes, and you can go back up to examples 1, 2, 3, or 4, the y-intercept, the x value of your y-intercept is always 0. So this means that that coordinate right there, 0, 2, is 12, is your y-intercept. So in this case, the y-intercept is going to be the point 0, 12 from your equation. Whenever we talk about the y-intercept, the x value is always going to be 0 for the y-intercept. Okay, then the x-intercepts. The x-intercepts are always the values that have the y of 0. So one x-intercept is negative 6, 0, and the other x-intercept is negative 2, 0. So in this case, this has 2 x-intercepts, which would be the coordinates negative 6, 0, and negative 2, 0. Okay? Now, to write the equations for that, I'm going to use my x-intercepts, because remember, for my equation, I'm going to start it off with y equals, and then my equation is going to have 2 factors, and the factors are always going to be the opposite of your coordinates of your x-intercept. So if one x-intercept is the coordinates negative 6, 0, it means one of your factors in your equation is x plus 6, the opposite of negative 6. If your other x-intercept is negative 2, 0, it means your other factor is going to be x plus 2. Okay, so that would be one of the equations. Now, to figure out what the other equation is, what you're going to do is you're just going to incorporate the idea of the area model. And you're going to multiply the x plus 6 quantity with the x plus 2 quantity, and you're going to simplify it out. by filling them out on the outsides here. Okay, and then we're going to fill out the inside. So filling out the inside of the area model, we get x squared. X times x is x squared. X times positive 6 is 6x. X times positive 2 is 2x. And positive 2 multiplied with positive 6 is positive 12. So simplifying this, I get x squared plus 8x plus 12. So your two equations that match up from this table, which I got from the x-intercepts, are y equals quantity x plus 6 multiplied with quantity x plus 2, and y equals x squared plus 8x plus 12. Okay, guys, so that's what I got for you there. So now what I want you to do is you're going to need your textbook. I want you to go to Google Classroom. I want you to look up Unit 5, assignment number 5 at Google Classroom, see what the problems are, do all the problems, and then fill out the Google form. Sorry, guys, I'm trying to get the recording to stop. Won't do it.